Hi, this is Stephen Breyer from Martin Valley Community College. I would normally in the class do this as sort of a demo. It's two of the homework problems not assigned that I'm going to go through. And this is from Stallings chapter 9. One of the problems is to take this binary number and convert it to decimal. So what I'll do is, starting from the right-hand side, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. And for the places where we have the 1s, those would be added together. So the 2 to the 4 is 16, plus the 2 to the 3 is 8, plus the 2 squared is 4, and that is, if I'm doing my math right, 28. So that is the 0, 2 to 1, 2 to 2, 2 to 3, 2 to 4. So that is the conversion of the binary number to this decimal. The next one, the reason why this is not assigned is the numbers larger than what I would have done on an exam. So we'll go through the exercise. If this is a hexadecimal number, that's a D. This is a hexadecimal number to come up with the decimal equivalent. So 16 to the 0, 16 to the 1, and 16 squared. And so just writing this out before I do the conversion, so D times 16 squared plus 5 times 16 plus 2 times 1, 16 to the 0 is 1, or if I'll be convinced, do the 16 to the 1, 16 to the 0, just to be consistent. So 16 squared is 256. Now the D, there's another video that goes through the making of the hex, but if you remember for the hex table, 0 to 9 in hex is 0 to 9. Right, so if we go, the 9 is the 9, and then the A is 10. So then B is 11, C is 12, and the D is 13. So this is 13 times 256 plus, well, in this case here, that's 16 to the 1, 5 times 16, that's 80. So plus 80 plus 1. I'm sorry, plus 2. Okay. And so the 13 times the 256, well, if we were doing this on paper, again, I wouldn't assign this on an exam because it's just way too much to do on an exam, especially under pressure, and if it's a 1-hour exam. But if we were to, so the 3 times 6 is 18. 1, 3 times 5 is 15, plus 1 is 16. 2 times 3 is 6, plus 1 is 7. 1, that's a 7. And the 1 times 256, this is 256. And so we're doing a sum of products here. That's an allusion to something else. 8, 2, 1 is 3. Carry the 1 and is 3. So that's 3328. So 3328 plus 80 plus 2 is the 28. That's 33, and then the 8. That's 3408 plus 2 is 3410. Okay. So if the reason why I didn't assign this as a homework problem is because I wouldn't give that much work on an exam. If I ask you to convert a hexadecimal number to decimal, it would be a little bit less math than what I just did there. Okay, so if we were in the classroom, these two that I just did here, the converting this binary to decimal and converting this hex to decimal, that would be two of the things that I would have done in class.